Hello everyone, I am Dr. Karunesh Srivastava from Department of Electronics and Communication Engineering, and today I am going to discuss the young slit experiment. So first of all, what is interference and what is the condition of interference? So when two or more wave follow the same path and there will be some interference and they will overlap to each other, then you can say there is an interference. So when we will observe the interference when the waves are in same phase, and you can say the waves that are traveling from source to destination is having the same wavelength, or you can say the coherent and monochromatic waves will cause interference. So for occurrence of interference, these two conditions are important, that is the wave should be coherent and the wave must be monochromatic. Now what is the young double slit experiment? So if light is a wave and interference effects will be seen where one part of wave front can interact with another part. So you can say the one way of studying the double slit experiment is we can pass the sun rays through a slit and we can see the effect of slit, and we can see the effect of slit on the screen. So if I am passing a sunlight or sun ray through the slit 1 and slit 2, you can see the rays will pass through this slit and they will appear. If I am not passing the slit, then the gap will appear like this, and if more than one slits are there, then we can get on the screen like this. So suppose I am using a single slit, I am using a double slit. If I am using a single slit, then light will pass through a slit and it will not interfere to each other. If I am passing the light that has been passing through the single slit, then you can say here the same wave that has been passed through a single slit or output of a single slit is passing through a double slit, then there is a interference inside this. So what is the interference? You can see here these waves are overlapping to each other, and you can see on this, or you can see the effect of this interference on the screen. So where the interference is maximum, the dark fringes will appear, and where the interference is minimum, the light fringes will appear on the screen. So young double slit experiment, the interference occurs because each point on the screen is not the same distance from both slits. So if I am sending a sunlight, I am sending the sunlight from the slit 1 to and slit 2, so it is not necessary that both the waves will travel the same distance. So depending upon the difference traveled path, you can see here I am passing the sunlight through slit 1 and slit 2 and the destination point is same. So what is happening here? The distance between the slit 1 and slit 2 is d, and they are appearing at this reaching at the same point. So what is going to happen? There is no phase difference, or you can say the theta is equal to 0 for this for these waves which are traveling through slit 1 and slit 2. So if the phase difference theta is 0, then there will be the bright fringe will appear, or you can say there will be the constructive interference. Same will happen here. If the phase difference, what is the phase difference between this? You can see here the phase difference between this and this point, this and this point, this and this point is same. Similarly, you can see here that for construction of bright interference, bright fringes, So here you can see that the light is traveling through slit 2 in this direction. After that, the destination point is this. So, it will bend like this and it will make the angle theta with this, with the midpoint of the slit 1 and slit 2. So, what is going to happen now? We have to check again whether the phase difference between wave 1 and wave 2 is 0 or not. So, you can see here that the phase difference between wave 1 and wave 2 is 0, and the extra distance travelled by the wave 2 is lambda. So, I am interested here only for phase difference. So, if the phase difference is 0, then you can say that there will be the bright fringes will appear, or the constructive interference will be there. Now, you can see here the phase difference is not 0 here, and there is a some phase difference between wave 1 and wave 2. So, the dark fringes will appear and the destructive interference will be there. So, it is clear the slit, the distance between the slit and a screen is fixed for all these three cases. I am observing only the phase difference between wave 1 and wave 2. If the phase difference between wave 1 and wave 2 is 0, then the bright fringes or constructive interference will appear. Otherwise, if the dark fringes, there is some phase difference, then the dark fringes will appear and the destructive interference will occur. So, depending upon the path length difference, the wave can interfere constructively, or if it is constructively interfering, then there will be the bright spot, and if there is a destructive interference, then there will be the dark spot. So, this is all about the constructive and destructive interference and bright and dark spot. Now, we can use this geometry to find the condition for the constructive and destructive interference. So, you can see here that the wave is travelling from slit 1 to slit 2. What is the path difference? The path difference is the extra path travelled, or you can see that if I draw a perpendicular from this point to this line, we can see here the extra path travelled by the wave 2, or the wave which is passing from the slit 2 is travelling this extra path. So, this extra path is nothing but the path difference, and this path difference can be calculated. This path difference can be calculated using this triangle. Suppose this angle is theta and the distance between these two slits is d. So, what will be the path difference? Path difference is nothing but this. So, you can write here the path difference is d2 minus d1 is d sin theta. Now, for the constructive interference, there will be the bright spot, and for the condition for that is d sin theta should be equal to m lambda, where m is equal to 0 to n. Similarly, for dark interferences or the dark fringes or destructive interference, this path difference should be equal to the odd multiple of the m plus 1 by 2 lambda. This is m plus 1 by 2 lambda, and this is m lambda. So, you have to remember this, whether you want to generate constructive interference or destructive interference, or you can say this is the condition for the constructive interference and this is the condition for the destructive interference, or you can say this is the for generation of bright spot and this is the condition for the dark spot. So, you have to remember this, d sin theta is equal to m lambda, and for the constructive interference, and d sin theta is equal to m plus 1 by 2 lambda for destructive interference. So, this is the important condition for double slit experiment. Now, we can see here How we have calculated, this is the again the same figure that I have discussed in the previous slide. So for calculating the part difference, we have to calculate this distance. So this distance is nothing but this angle is theta. This is written here. So d sin theta is equal to m lambda for constructive interference, and d sin theta is equal to m plus 1 by 2 lambda for destructive interference. So again, this is the condition. So how the bright fringes will appear? So I am going to consider this, or a constructive interference will appear. So consider this, if the angle theta is very small, then we can consider that sin theta is nearly equivalent to tan theta. So what will be the value of this tan theta? I have considered here, this is angle theta. This has been considered that this is angle theta. So, and the distance between the slit is d, distance between slit and screen is L. So where the spot or bright or dark spot will appear is y distance away from the center. So for constructive interference, d sin theta is equal to m lambda. So what will be the value of y? At what distance from the center the fringes will appear on the screen? So you can calculate this, y bright will be equal to, this is nothing but I have already calculated for constructive interference, d sin theta is equal to m lambda, and m is equal to 0, 1, 2. So again I have seen here from this triangle, this is y, this is L, this is L, this is y. So tan theta is equal to y by L. So I can put here sin theta is equal to y by L. So you can write here d y by L is equal to m lambda. So what will be the value of y? Y bright will be equal to m lambda L by y. Sorry, m lambda L by d. I have to calculate this. So in this way we can calculate the distance of the from the center where the dark or bright fringes are appearing. Now again, how this dark fringe will appear? So I have already discussed, I have already told you that the sin theta is, if theta is very less, then sin theta will be nearly equivalent to tan theta, or sin theta will be equal to tan theta. So we can calculate sin theta is equal to y by L, and the condition for this and the condition for this destructive interference is d sin theta is equal to m plus 1 by 2 lambda. This is lambda. So what will be the value of y? Y again you can calculate by putting this sin theta is equal to y by L. So you will get y dark is equal to m plus 1 by 2 L lambda by d. So this is the value of, or you can say this is the distance from the center of the screen where the dark or bright fringes will appear. This, the value of y dark and y bright is giving this information. Now the resultant, and we will find the resultant intensity due to superposition of the two interfering wave. Now let suppose this, first of all I am passing this wave through the single slit. After that, this output of the single slit will pass through this slit 1 and slit 2. Now what will be the resultant intensity at point P? So let us be a narrow slit illuminated by monochromatic single wavelength. Source S1 and S2 are two similar parallel slits. S1 and S2 are equidistant. So you can say that these are the equidistance. From suppose the waves from S reaches S1 and S2 in the same phase, it means the wave that is reaching to the S1 and S2 is coherent, and these coherent waves are again passing through this slit 1 and slit 2. So suppose the waves from S1 reaches from the S reaches S1 and S2 in the same phase. Beyond S1 and S2, the waves proceed as if they are started from S1 and S2. So, before passing through this, you can say that these waves are passing through after passing through the slit S, these waves are passing through the slit 1 and slit 2. Now, how will you calculate? So, for calculating this, we have to find the path difference. We have to find the path difference. After that, phase difference. After that, I will find the resultant wave. So, what is the path difference? Path difference can be easily calculated. What is this? The distance travelled from S2 to P, the distance travelled from S1 to P. What is the path difference? This is the equal distance. So, we have to find, you can say, what will be the path difference? Path difference is nothing but S2P minus S1P, greater minus lesser. So, what will be the value of S2P minus S1P? We will calculate this. So, I am putting here only the path difference. So, how will you find the phase difference? Phase difference is nothing but 2 pi by lambda into path difference. So, this is the standard formula. Phase difference is equal to 2 pi by lambda into path difference. So, we have find this. We have supposed that two waves are traveling from slit 1 to P and or you can say from S1 to P and S2 to P. So, what will be the how will you calculate this path difference? So, suppose the wave which is traveling from S1 to P is having A1 amplitude, or you can say the wave which is traveling from S1 to S2, Y1 is equal to A1 sin omega t and Y2 is equal to A2 sin omega t plus phi, because there will be some phase difference between these two waves which are passing from the slit 1 and slit 2, where omega is the frequency of two wave and delta is the phase difference. So, now we can calculate, it should be very clear that two waves are passing. So, one is in another phase and another these two waves have the different phase. So, I have created some phase difference between these two waves. So, what will be the resultant wave which is passing through this? Y is equal to Y1 plus Y2. So, by the principle of superposition, when two or more waves are simultaneously reach at the point, the resultant displacement is equal to the sum of the displacement of all waves. So, what will be the sum of the displacement of all the waves? Y1, I have already supposed this, Y1 is equal to A sin omega t and Y2 is equal to A2 sin omega t plus delta. How will you find this? How will you find the resultant amplitude? Now, A1 sin omega t as it is, A2 sin omega t plus delta, sin A plus B. I am using the mathematical formula for this, sin A plus B is equal to sin A cos B plus cos A sin B. I am using this expansion for expanding this sin omega t plus delta, A2 sin omega t cos delta plus A2 cos omega t sin delta. I am again going to simplify this. I am taking sin omega t common from this and this. So, if I take common sin omega t, I will get A1 plus A2 cos delta plus cos omega t A2 sin delta. Now, I am replacing this amplitude by the another variable. A1 plus A2 cos delta is equal to R cos theta. A2 sin delta is equal to R sin theta, where R and theta are new constant and r will be the, now you can write this resultant displacement y is equal to sin omega t r cos theta. How you are getting this? Sin omega t r cos theta plus cos omega t r sin theta. Sin omega t r cos theta, cos omega t r sin theta. Same expression is written here. Now you can further use the mathematical formula, that is sin a plus b. So you can write this y is equal to r sin omega t plus theta. Hence the resultant displacement will be equal to, I have suppose this a1 plus a2 cos delta is equal to r cos theta, a2 sin delta is equal to r sin theta. So for finding the value of r, or you can say the resultant amplitude, what will I do? I will solve these two equations. So for solving this, I will take the square of this and this. So what will be the value? R square sin square theta is equal to r square sin square theta is equal to r a2 sin square delta. This is sin, not cos. And r square cos square theta is equal to a1 plus a2 cos delta square. So by adding these two, you know the formula, sin square theta plus cos square theta is 1. So what will you get? R square cos square theta plus r square sin square theta is equal to a1 plus a2 cos delta square plus a2 cos delta square. This is sin, not cos. So what will you get here? When you will expand this, you will get ax plus y ka whole square. What will be the a1 square plus a2 square cos square delta plus 2a1 a2 cos delta plus a2 square sin square delta. So you can simplify this. This a1 square is as it is. a2 square cos square delta plus a2 square sin square delta is nothing but a2 square plus 2a1 a2 cos delta. So this is the resultant displacement of the two waves, resultant amplitude at point P. So how will you calculate the intensity? So resultant amplitude is this, r square is equal to a1 square plus a2 square plus 2a1 a2 cos delta. So the intensity at point P is directly proportional to the square of the resultant amplitude, which is given by I is equal to r square, and r square is nothing but a1 square plus a2 square plus 2a1 a2 cos delta, where delta is equal to 2 pi by lambda into path difference, and this is equal to 2 pi by lambda into s2 minus s1. So in case of interference, the resultant intensity at point P is not just sum of the intensities of the individual waves. So the resultant intensity at P will be equal to this, and the intensity I will be maximum. What will be the maximum value of this intensity I? Cos delta, when this cos delta will be maximum, this will give maximum value. When cos delta is minimum, this will give minimum value. So I am putting here cos delta is equal to plus minus 1. What is the maximum and minimum value in one cycle? So this is plus minus 1. 1 is maximum value and minus 1 is minimum value. Or you can say when cos delta is equal to plus 1, so the phase difference will be equal to delta will be equal to 2n pi, where n is equal to 0, 1, 2. So phase difference delta will be equal to 2n pi in that case. And what will be the path difference? Path difference is nothing but 2 pi by lambda into phase difference. Phase difference is 2n pi. Sorry, this is a phase difference. So path difference will be equal to 2 n pi. So I have written here delta is equal to 2 pi by lambda into path difference. So we have to calculate here path difference. So path difference will be equal to lambda by 2 pi into this 2 n pi. So 2 pi n will be cancelled out. So it will be equal to n lambda by 2. So we can find the maximum intensity. So maximum intensity is I maximum will be equal to A1 square plus A2 square plus 2 A1 A2 cos delta is 1. So you will get here A1 plus A2 ka whole square. Now I have already told you that this intensity is nothing but the intensity is directly proportional to square of the amplitude. So I is directly proportional to A square. It will be equal to, so we can calculate here, we can write here I maximum, this is the amplitude of phase 1, this is the intensity of phase 1, this is the intensity of phase 2 wave 2, and this will be equal to 2 under root I1 into I2. So the intensity is nothing but I maximum is equal to I1 plus I2 plus 2 under root I1 I2. This is the maximum intensity and this is greater than the summation of two separate intensities. If I write here the intensity of wave 1 is I1, intensity of wave 2 is I2, the summation of these two intensities is I1 and I1 plus I2, but this maximum intensity is greater than this I1 plus I2. Now the intensity I is minimum when cos delta is equal to minus 1. So when cos delta is equal to minus 1, so delta will be equal to 2n plus 1 pi. So for what will be the phase difference? Delta is equal to 2n plus 1 pi. Now path difference will be equal to, again you can find using this formula, phase difference is equal to 2 pi by lambda into path difference. So path difference will be equal to 2n plus 1 lambda by 2. So I minimum will be equal to A1 square plus A2 square, I am putting in this formula, A1 square plus A2 square minus 2 A1 A2. This is nothing but A1 minus A2 ka whole square. So you can write here the minimum intensity is less than the sum of two separate intensities. If I write individual formula, if I write this formula in terms of intensities, then we can write here I1 plus I2 minus 2 under root I1 I2. So summation of two intensities, this I minimum is less than the summation of intensities of individual waves. So you can say here I maximum is greater than the summation of intensities of individual wave and I minimum is less than the summation of intensities of the individual wave. It means, so summation of these intensities will lie in between this I minimum and can lie between I maximum and I minimum. So this is the method how can you find the maximum and minimum intensities, and using this formula you can also calculate the path difference, phase difference and intensities of the waves which is passing through the double slits. So this is all about the calculation of path difference, phase difference, intensity, how will you calculate maximum and minimum intensity, and with the help of this lecture you can easily calculate all these things. Thank you.